Welcome, my students as well my viewers. Today, I am going to start this Cournot model, oligopolistic market, and that too in a case of duopoly. This Cournot model is the oldest, rather, the most earliest model of duopoly. Augustin Cournot from France, and that gentleman, a great mathematician of France, he gave this model in 1838. But this model remained unnoticed till 1880, when Walras recognized, he identified the model, and Leon Walras, a great man in economics, he called the intention of the world towards this model. As a reaction of this model, and as a critic rather, reaction as well as a critic, another model came in 1883, given by Bertrand. Thereafter came another model in 1895 by Edgeworth. And as a refinement of classical model, two models in 20th century appeared. That was given by Chamberlain and Stackelberg. So among classical models, we can take these five models. Cournot, that appeared in 1838. Thereafter appeared this Bertrand model that appeared in 1885. Edgeworth, an Italian. That model came in 1895. And then Stackelberg and Chamberlain. The difference, these five models can be grouped under two categories. The first three categories, rather the first three models, in those models, the mutual interdependence between the firms is not recognized. A firm operating as a duopolist, he assumes that whatever I produce, my rival will remain his production a constant, a very naive assumption, a very unrealistic assumption. So, in those upper three models, in Cournot model, one monopolist assumes that one rival one will keep their level of production constant. In Bertrand model as well as in Edgeworth model, there it is assumed that the rival will keep their price constant. So that is and this assumption is in modern economics is being called zero conjectural variation. So these three models operates with zero conjectural variations, and in these two models, Stackelberg and Chamberlain, retaining all the qualities of the classical model, these two models, it is recognized the mutual interdependence between the rivals or between the producers operating in the duopolistic market or the oligopolistic market. So this is the difference, and this is how we can just classify these five models. In upper three, there is zero conjectural variation, and these two, there is some amount of conjectural variation. This is what. Today we are concerned with the Cournot model. So, first of all, this model is a non-collusive because there is no agreement, there is no mutual interdependence, these things are not here. So, it is called a non-collusive, and both the producers have the homogeneous product, or they sell the homogeneous product. So, first remark about this model would be that this is a non-collusive, homogeneous duopoly model. Right. Secondly, this was given by French Augustin Cournot in 1838, and it remained unnoticed till 1880, when Walras called the attention of the economists. Right now I have spoken it. Thirdly, in this model, Cournot assumes that there are two producers and they own mineral water spring, both own mineral water spring, separately with zero cost. So here this model operates with zero cost. This is whatever is revenue, that becomes a profit. So it's a zero cost model. So use example of two firms, each owning a spring of mineral water with zero cost, right? They operate in a market, this is another feature of this model, that both the producers operate in a market which have a linear demand curve downward falling. A downward falling demand curve is the market demand curve. Each firm does not recognize mutual interdependence, right now I have spoken. Each firm does not recognize mutual interdependence. This is called zero conjectural variation. Now, we shall see when we come here to explain this diagram. There will be action and reaction. There will be a chain of action and reaction between these two rivals. So after various rounds of action and reactions between the two players, eventually a stable equilibrium is achieved, reached. So after action and reactions, finally a stable equilibrium is reached with each firm producing 1/3 of the total market. That is, I am going to show there. 1/3 of the total market, and each produces 1/3, and thus the total production would be 2/3. So we can say that 1/3 of the total market remains unfulfilled. Yes, that's another feature of this model. That a Cournot, we shall see there that we shall get a Cournot solution where 1/3 of the total market remains unfulfilled, which is a part of the perfectly competitive market demand curve. That we shall see there. This is what about the production by each firm. If now as a rule or as a generalizations, we can say that in a model, if we take n firms instead of 2, then each firm would produce 1/n plus 1, and the total production would be n/n plus 1, and of course that will be the less of the total demand or the total market. Here too, which is happening here. Each firm sells at a price. Now let us see what happens in case of price. Each firm sells at a price. That price should be smaller than the monopoly price and larger than the competitive price. Whatever Cournot solution is going to give the price, which I've seen diagram, that price should be smaller than the monopoly price and larger than the competitive price. So here it is said that each firm sells at a price higher than competitive price and smaller than the monopoly price. So output of Cournot model is 2/3 of the perfectly competitive equilibrium output, and price of the Cournot solution is 2/3 of the monopoly price. This price would be the 2/3 of the monopoly price, less than monopoly price, and this one, and this is the 2/3 of the total price, total demand. That is, I am going to explain this. That is very interesting to realize that this is how we shall get the solution. This model is an example of Nash equilibrium. Yes, and another final point about this model, and why it is a Nash equilibrium. Because in this model it is assumed that in each period and each firm maximizes their profit. They don't have any tendency to alter their own equilibrium. So in each period they maximize their own profit. That is why this is rather a final example of Nash equilibrium. So we may say that this Cournot equilibrium is stable as well as the Nash equilibrium. So so it is an example of Nash equilibrium, as in each period firm maximizes profit. And when we go to make a comparison between the Cournot solution with the monopoly solution and the perfectly competitive solution. And it's quite evident in the diagram that as far as the output is concerned, this Cournot output is less than the perfectly competitive output, and price of Cournot is less than the monopoly price. One thing. As far as this monopoly output, then this Cournot output would be larger than the monopoly output. And in case of perfectly competitive market, in this case, perfectly market, there is no profit, so zero profit. Then the comparison between the monopoly profit and the Cournot profit, then Cournot profit is less than the monopoly profit. So this is how solution is obtained in the Cournot model. Now let us come on the diagram. This AB, I will call it here, and this AB is the initial demand curve or the market demand curve. Let us assume, just to explain it in a more intelligent way, let us assume that total market is 30 and this is the perfectly competitive market. Here I have written it. So this 30 is the competitive, this is the perfectly competitive market, right? Now, out of two rivals, A and B, A starts, just one thing I must explain, rather it would be more informative for the viewers, that if any, because both the firms are operating as a monopolist, so this is a case of monopolist where there is no cost. So this is a case of costless monopoly to start with. So this regarding this one, costless monopoly, I must explain, or rather you must understand that well, if this is the demand curve and monopolist has no cost, then his profit is his revenue. Now he will maximize his revenue. Then to maximize his revenue, his marginal revenue has to be zero. Total concept has to be maximized, so this marginal concept has to be zero. Now, if this is AR curve, then corresponding to it is a MR curve, and at the midpoint of the demand curve where it is unitary elastic, MR happens to be zero. So this implies that a costless monopolist would always operate at the midpoint of the demand curve. When he does have cost, then he will move and he will operate in this region. This is a case of monopolist which does not have any cost. So a costless monopoly to maximize his profit, that is to maximize his sales or revenue, his marginal revenue has to be zero, and marginal revenue is zero corresponding to the unitary elastic demand curve, and this is the midpoint. This comes in this diagram. This is, I have to explain. Now let us explain this diagram. Initially let us assume that there are two firms A and B, say. A starts, then he is a monopolist. He would be at the midpoint of the demand curve, and initially he will just operate, or he will just produce half of the total demand, so 15. Initial monopoly demand is 15 and monopoly price is PM. Now, for firm B, this portion remains the average revenue curve for firm B, because firm has operated up to here. So the remaining part becomes the average revenue curve for the firm B. Now for this demand curve, firm B would operate at the midpoint. So he will somewhere operate here where marginal revenue is zero. This is called action and reaction. This action and reaction continues till a stable solution is achieved, and this stable solution says that this Cournot output is 2/3 of the total output. Yes, 2/3 of the total output, and total output is here, we have taken 30, so this is 10, so this must be 20. Yes, this is our Cournot output. Now for having price, we must go to the demand curve A, and corresponding to A we have the price. This is the Cournot price. This is 2/3 of the perfectly competitive output, and this is 2/3 or 2/3 of monopoly price. This is an important feature of this model, that ultimate, whatever solution is obtained, this solution for output is 2/3 of the competitive output, and 2/3 of the monopoly price. This is the solution. Now, one thing to explain more regarding this model. This Cournot solution was obtained when both players did not recognize any kind of interdependence, of course operating with zero conjectural variations. Now let us see, if they make a collision and they go to the monopoly, then let us see what happens. So if they make a collision kind of monopolization and they make a monopoly, then if they become a monopolist, then this is the demand curve. They will operate at here, absolutely. And corresponding to this here, this would be the monopoly output. That's why this is monopoly output. And corresponding to this will be the monopoly price. So this is monopoly output, this is monopoly price, this is a Cournot price, and this is Cournot output. And as far as the profit is concerned, for the perfectly competitive market, price is zero. So there is no chance of any profit for perfectly competitive market. But whatever is the profit, so profit here says that this profit OPME15, this profit is much larger than PCA20. This profit is monopoly profit. And Cournot profit is this one. So this Cournot profit is smaller than this monopoly profit. So so we may say that profit in Cournot solution is less than profit in a monopoly. This is quite evident in this diagram. So this is what about the Cournot solution and Cournot the model regarding the diagrammatic representation of this model. Now, in another video, I am just going to make it just a video following this video. I am going to say or going to explain that how each firm is producing 1/3 of the total market. Of course, this will involve a little bit of GP. I will explain there, and it is quite evident that how we reach at this equilibrium 1/3 mathematically. So with a little bit of mathematics, I will be explaining in another video. And for regarding this one, this is what I have to explain. If any kind of query or question or interest, you must mention in the comments. And this model would extend up to the mathematical explanation. I will just finally explain this model with mathematical derivations with a numerical sum. But for today, this is all. Thanks.